All right, so let us look at some rectangle questions here. Here comes the first one. POST is a rectangle, so let me try to draw a rectangle for you. So then, let us say this is POST, and then PO is equal to 8, and OS is equal to 12. Find the perimeter. That's rather simple because opposite sides are equal to each other. Then we realize that this is 20, that's equal to 20, so we get 40 is our perimeter. Find PS. How do you find the PS? That's the in fact hypotenuse of a right triangle. So if I were to call that as x, then we get to realize 8 squared plus 12 squared is equal to x squared. So we get 64 plus 144 is equal to x squared. So then we get to realize that this is equal to 208 is equal to x squared. Then I believe that we can factor this one out. So 208 when you break that into 4, then you get to see that that's 52. And then you can break 52 with another 4, then we get 13. So then the value of x, which is PS, is equal to 4 square root of 13. Find the area of POST, which is area, so 8 times 12, which is equal to 90. 6 becomes the answer. All right. The length of the rectangle is 1 less, so I'm going to draw another rectangle here. 1 less than twice the width. So length of the rectangle is 1 less than twice the width, while this one is width. If the perimeter of the rectangle is 36, what's the, so perimeter, that means this is W, this is 1 less than twice the width. And when you combine them together, we get 6W minus 2 is equal to 36. So then, when you combine them together, we get 6W is equal to 38, and W becomes 19 over 3. Then, of course, in this case, we are trying to say that this is 19 over 3. Then this is 38, 2 times of that, so 38 over 3 minus 2, or minus 1, rather. Then it becomes 35 over 3. So then when you find the area will be equal to 19 over 3 times 35 over 3. So that becomes our final answer. Number 3, the diagonals WR and ET of the rectangles meet up at Y. So then, once again, if I have W, E, R, T, and diagonals, I have them over here, I have them over here. Now, given that WY, actually Y is right over here, WYE is equal to X. And find ERY. Let me call that as A. And then YRT, let me call that as B. To find A, we can easily see that yellow one is a triangle where X is the exterior angle. And then we can easily see that, not only that, here we have this length must be equal to this one. In fact, all 4 line segments are equal in a rectangle. So since this is A, then this one must be A as well. Then since x is an exterior angle, so a plus a, sum of the two non-adjacent angles must be equal to x. So we get to realize that x equals 2a, then a, we know that to be x over 2. So that's equal to x over 2. But another thing is, because a and b, they add up to be 90 degrees, so b must be equal to 90 minus x over 2. Simple as that. All right, number 4. So radius is 9. That means let me just highlight the radius here for you. So this is radius, and that's radius. And so is the other line segment, but I'm not going to do that right now. But did you realize that if I connect O and then this intersection between the rectangle and a circle, that would be also radius as well, meaning the purple one. Why? Because coming from the center to the point on the circle. Therefore, the purple one should be same length as the orange one as well. But at the same time, purple one is has another purpose, which is the diagonal, the green diagonal, and then purple diagonal, they are equal to each other. Why? Diagonals are congruent in a rectangle. So that's why we get to realize that the green diagonal is congruent to the purple diagonal, but purple diagonal is congruent to the yellow line segment, which happen to be 9. So therefore, all of them has to be 9. Then what is length of RQ, which is the green diagonal? That's 9 as well. Number 5. I have 36 inches by 24 inches rectangular painting. So I have rectangular painting that looks something like this, let us say. This is 36 and then 24. But I would like to place a frame that is 2 inches wide around the painting. So I have something that's a little bit bigger. Maybe make it a bit bigger so that a bit easily be able to see this one. So they're all 2 inches around. If the material, how much will the frame cost? So this is 2 inches. That means to find the area between these two rectangles, we have to find the outer dimension. So this is 2 inches here, 2 inches here, so we get 40 on this one. 2 inches here, 2 inches here, so we get 28. Then what I have to do is I have to find the this small area. Then what do I get? I'll be getting 40 times 28 minus 36 times 24. Now, so I have to calculate this one. For whatever area I be getting, I just have to multiply that by 1.5 because that's the cost per square inch. So once I have done that, then that would be my answer. All right, number 6. What kind of quadrilateral do you get when we connect the midpoints of the side of the rectangle? Now, so I have a rectangle. Let us try to see midpoint would have been somewhere around here. Somewhere around here. So is this one. So is this one. So I'm going to connect those midpoints using the red. So here. Then what kind of shape is the red quadrilateral? You see, since this is the midpoint, it divides this upper line segment into 2 equal parts. So as these two. Since opposite sides are equal to each other, we realize that each segment are equal to each other as well. Same thing for here. These two are equal to each other because this point is a midpoint, but so as the other two sides. And then we know that all the angles are right angles. Then what have we created? We just created 4 congruent triangles. Since we have 4 congruent triangles, the red line segments happen to be corresponding parts of the congruent triangles. Therefore, they all must be equal to each other. Those 4 circles ones are equal to each other. Oh, wait a minute. Quadrilaterals, that has all equal size. What is that? It's a rhombus. So that would have been our answer. Let's look at the last one. EFGH is a rectangle with area 48. So I'm gonna just call this one as E F G H. But the thing is, EGJI is a rectangle such that H is on. So that means I have to have uh, this red one has to be over here as well. And then so red one must be the new rectangle. So EGJI. So then let me call this side EF as side A and then FG as side B. Then we know that A times B must be equal to 48. Now, and then let me call this line segment, the red one, as C, and then this length as, or this length as D. Then what is CD? That's our question. But did you realize that since the red one is a rectangle as well, wait a minute, I can copy that line segment and bring it over and connect it from point H to the side C. What does that become? It becomes the height of the bottom triangle. So in fact, if you look at the yellow triangle, we get to see something quite interesting. That is, how do you find the area of the yellow triangle? If C is the base, then this line segment will be the height, which is same thing as D. So 1/2 C times D, because C being the base, D being the height, because it's perpendicular. That should be the area of the yellow triangle. But another way for you to look at the area of the yellow triangle is, since this is A, bring it down here. This must be A. Since this is B, bring it over here. This is B. So B becomes the height, A becomes the base. So 1/2 AB. But that means if I were to cancel out 1/2, AB must be equal to CD. So since AB is 48, CD must be equal to 48. So then what is the area of the new rectangle? 48. There it goes. So with this one, we are done with the rectangle, and I'll see you later. Bye-bye.